All right, welcome to Unit 6, Day 2 notes. This is going to be on similar polygons. Let's get right into it. The first thing I want us to know or remember or think about is this little symbol right here is going to stand for similar. So this is going to be our symbol for similar, and really I'm going to explain it out, and that's going to be our similarity, okay? So whenever I talk about polygons being similar, or are they similar, I'm going to use that symbol to say that. All right, let's move it on. Similar polygons. Angles are congruent and sides are proportional. This is the key to this. Are the angles congruent and are the sides proportional? Okay, and we learned about proportions yesterday, which was Friday for us, and this is now Monday. So on Friday we learned about proportions. We want to know if our polygons are going to be similar, that the angles have to be congruent and the sides have to be proportional. As I look at this one, I notice that this is it's going to be a trapezoid, but it's definitely a quadrilateral for sure, right? It's a four-sided polygon. And then I notice that all four angles of each of these polygons match. Because I've got one tick mark to one tick mark, 2 to 2, 3 to 3, and 4 to 4. Now as I look at this, I could do the proportions of it. Is 12 over 9 going to be basically equal to 8 over 6, which is going to be 16 over 12, and last but not least 20 over 15. And what I'm basically doing there is basically saying, are all of these in the same proportion? Well, 12 over 9 is going to be, what is that? 4/3. This is going to be 4/3, 4/3, and 4/3. If I reduce every one of these, and notice that all of them are 4 over 3. So they are proportional. So I know that these two figures here are similar. Well, I can also do corresponding for this, and corresponding angles and corresponding sides. And remember, when we're doing corresponding, when we're talking about a congruent polygon to a congruent polygon, we always want to have the order being matters, okay? The order matters. So we have to go angle to angle. So I look at this, and I know that angle M is congruent to angle H. So corresponding angles M and H. I've got L and G. I've got K and F. And I also have N and J. N and J. Conversely, I want to look at the corresponding sides. I'm going to go 1 to 2, so I'm going to go M, L, and that's going to correspond with H and G. So that's going to be my and, H and G. And I'm going to write the second side on below it. And this is going to be my and symbol. So everybody goes, what? So M and L and H and G. How about 2 to 3? Okay, 2 to 3. L to K. LK. 2. G to F. G to F. That's not a really good looking G. Let's try that again. L and G to F. I'm going to go 3 to 4. 3 to 4. K to N. So K to N. And that's going to give me F to J. F to J. And then last but not least, 4 down to 1. That's going to be N to M and J to H. N to M and J to H. All right, and that gives me the corresponding angles and the corresponding sides. Remember, order always matters. Okay? All right, let's move on. The two quadrilaterals are similar. Write a similarity statement. So we've already said that they are similar. They are similar, so we know that. So we're going to go in order. I'm going to start on this one at K. So I got K, L, M, and N. All right? In order to make sure I can write this correctly, I have to have the order. And I always wanted to make sure order matters. Okay? When doing this, the order matters. Well, if I started with K, the one that's similar to it is going to be point P. And I'm going to go in the correct order. Q is next, followed by R, and last but not least, followed by S. Okay? So when writing this, when we're writing the similarity statement, this is going to be the polygon KLMN is similar to the polygon PQRS, making sure that the order of them match. Okay? All right, moving on. Decided the figures are similar. Well, how am I going to do that? Well, I'm going to look to see if the angles are congruent and the sides are proportional. If yes, write a similarity statement. All right, so let's look at the first one, A. And this is going to be triangle A, B, C. And is it similar to triangle DEF? DEF. That's what I'm asking. Are they similar? Well, I notice that I've got one tick mark for an angle and one tick mark an angle. I don't know all the angles, do I? But I know one angle for sure is. Well, let's look at the sides. Let's see if they're proportional. So let's go AB, side AB, it's 8, has to be corresponding to side DE, so that's going to be 7. Is that equal to, let's go side BC, which is 6. Is that proportional to side EF, because that is its corresponding side? And is AC, which is 12, is that corresponding with DF, which is 11? Well, how do I find this? Well, the easiest way is to take a calculator, and let me find mine. And as I look at the calculator, I can take 8 divided by 7 in the calculator. 8 divided by 7. Well, that gives me 1.14. Well, I can easily look at and see if 6 divided by 5 is the same thing. So 6 divided by 5. Well, that's 1.2. I already know, since the sheer fact that these do not match, that they're not similar. I'm going to go ahead and do the 12 divided by 11, because that one is 1.09. Well, I've proven that these are not similar. So answer to this is no. They are not similar. They are not similar. All right, let's look at example B. Example B. Well, the first thing I notice about this is I've got 2 angles already. This one, and then I've got 2 tick marks here. Well, remember when we talk about triangles, if I know 2 angles of one are congruent to 2 angles of the other, then the third has to be congruent. So I know that these have to be congruent. So I know that all my angles are congruent. I know that right now. Okay? What I don't know is, are the sides proportional? Are the sides proportional? Well, I can check that, and I can look and I can go, is side XA proportional to side MN? Well, that's going to be 9 over 6. And then is that going to be proportional to, what is that, 15 over 10? And is that proportional to 12 over 8? Well, if I reduce these down, I can do this without a calculator. 9/6 is 3/2. 15 over 10 is 3/2. And 12 over 8 is 3/2. When I reduce those fractions, notice that all 3 of these are the same. So these triangles are similar. So let's write a proportion. Let's write the similarity statement. I'm going to say that triangle AXR is similar, notice my symbol, is similar to triangle. Since I started with A, I must start with N, MT. All right. So I've decided the figures are similar, decided the first one was not, decided the second one was, and we've proven both of those. And then if it, yes, write a similarity statement. We've done that. Triangle AXR is similar to triangle NMT. All right. Reminder that if you need to pause at any time, try to catch up, do all that kind of stuff, just make sure you hit pause button, get everything written down, and then move forward. Reminder also to ask any questions in class. Happy to answer them for you. All right. Last part of the notes for today. We're only doing one page, and this is the end of it, okay? The first part of this, it says scale factor. Scale factor. And when we use the scale factor, we're always going to use the letter K, okay? So K equals. K is going to be representative scale factor. So whenever you see K equals something, that means scale factor. All right, it says the ratio of the lengths of the corresponding sides of polygons. The ratio of the lengths of the corresponding sides of polygons. And remember, you can always simplify, so you don't have to leave fractions nice and big. You can simplify when doing this, okay? Perimeters of similar polygons. Ratio of perimeters is the same as the scale factor. That's a pretty big statement. That's a pretty big statement. It says the perimeters of similar polygons. What is the perimeter? Well, the perimeter is when you add up all the sides, right? So the ratio of perimeters, the ratio of the perimeter of the first polygon compared to the perimeter of the second polygon is going to be the same as the scale factor. We're going to use that information as we progress, okay? That's pretty big news. All right, so let's look at this. Using similar polygons, ABCD and GHIJ. We already know they're similar. We told you that, okay? They're similar. So let's go ahead and start finding some stuff. Find the scale factor of ABCD to GHIJ. All right, so I want to find the scale factor. Well, how do I do it? Well, it's the ratio of the lengths of the corresponding sides of polygons. Well, if I look at these two polygons, I know 8 is to y. Well, I can't really find the ratio there. X is to 8. Okay, those are the bases. I can't do that. I've got 11 to 5.5. Well, I can do that. So 11 to 5.5. Now, reminder that I'm going from ABCD to GHIJ. That's why I'm using 11 on top, because it corresponds with that polygon, ABCD, to GHIJ, which is on the bottom. 11 divided by 4.5 or 5.5. Well, that becomes 2 over 1. 5.5 is half of 11, so I'm 2 over 1. That is my scale factor. K is equal to 2 over 1. Find the scale factor of GHIJ to ABCD. Well, really, I'm just going to flip what I just did here. I'm just going to flip it. Because ABCD to GHIJ, I'm just going to go GHIJ to ABCD. So I'm going to go 5.5 over 11. Well, in essence, I'm just going to flip it. 1 over 2. So my K is equal to 1 over 2. That is my K factor. All right, the third part of this, it says find the values of X and Y. Well, I want to set up proportions to find this. I want to set up proportions. So find the values of X and Y. All right, well, since I can use the ratio of perimeters is the same as the scale factor, I can use the scale factor. So if I want to find, let's say, Y here, because I'm going to go at the top, I can go 8 is to Y. 8 is to Y is equal to what? Well, 2 is to 1. 2 is to 1, which is the same thing as saying 11 is to 5.5. Remember, I've already done 11 to 5.5. It gave me my scale factor. So I can nice and simplify, right? That's what I've done, is simplify that down to 2 equals 1, or 2 over 1. Now it's a pretty easy numbers. Cross multiply, remember, solving proportions, I'm going to cross multiply. So what do I have? I have 2y equals 8. Divide by 2, y is going to be equal to 4. So I found that one. Now, let's find the value of x. Well, I'm going to use the same idea. I'm going to have x over 8. And since I'm going from here to here, I'm still going to use 2 over 1. Well, that becomes, and when I cross multiply, x equals what? 16. So x equals 16. Have I found the values of x and y? I have. I've used my scale factor as part of it. I could have done x over 8 is to 11 over 5.5, but I'd already figured that out up here. Okay? I've already figured it out. The last part of this, find the perimeter ratio of ABCD to GHIJ. Hey, aren't we going to use the perimeter similar polygons? This information right up here, we're going to use that. Okay? So let's think about that. I've already found x. What was x? 16. So I know all four sides, right? And when I look at this one, y is 4. Well, I also know this missing side is 5.5, right? It's 5.5 because this is 11 and this is 11 and they're congruent sides, right? So that's going to be 5 and 5. So now let's just do this. Here we go. Let's do 8 plus 11 plus 11 plus 16. The perimeter of ABCD, right? ABCD, 8, 11, 11, and 16. That's going to go over 4 plus 5.5 plus 8 plus 5.5. And what is that going to be equal to? Well, let's add them up using the calculator. Well, I get 46 over 23. Well, in the calculator, take 46 and divide it by 23. What are you going to get? Well, you get 2 over 1. And if you think about that for a second, didn't we find the perimeter ratio is the same as the scale factor? I just proven what I've given you, what I've told you up here, that the ratio of perimeters is the same as the scale factor. I just proved to you in this last bit that if I'm going to find the perimeter ratio, well, since I already know the scale factor, I already know the perimeter ratio. It is 2 over 1. All right, hopefully you had a good weekend. Ask any questions, happy to answer them. Have a good day.